Hi, in this video we're going to be trying to fix up this Neewer GL25C RGB LED light. And this is used for things like video or video streaming. Now I saw this on eBay for spares or repair, and I think I paid £19 for it. It was advertised as just not doing anything, like no power, and they normally retail for round about £120. So let's get it out of the box. It does Wi-Fi and Bluetooth and things as well, so it might be interesting, this one. So let's get it out of the box. Right, so we've got a desk mount for it there. This is the main light here. We've got a power lead and a power supply. And I think there's a little swivel head there in the box as well. So I'll get the power supply out the box and the light, because that's the only things that we really need to be looking at. I don't need the destruction. What's this? Warning, please do not disassemble without authorization. Well, that could be a problem, couldn't it? Not. Right. I'll get this out of the way. And let's plug the power supply in and plug this in and see exactly what it's doing. So I might use the dim bulb tester. I've had a few people asking about this. And all it is just a bulb here, just wired in series with the live of the socket. And what happens is, if there's a short on this, all that'll happen is it just makes the bulb light up. So I'll switch that off a sec. Let's plug the power in. Now this has got a display on the back of it that shows lots of different information and settings and things. So let's just plug this in and let's switch it on. And we get absolutely nothing. So I think the first thing we need to do then is try and eliminate whether the problem's in here or with the power supply, because it could just be the power supply that's faulty. So let's get the test meter and we'll just go on to volts DC. And this power supply is 15 volts with a maximum output of 3 amps. So let's see what we get on this. I've got 15 volts. Now, let's just try putting a load on the power supply, because it could be that the power supply is still faulty and breaking down under load or something. So, got some LED strip light stuff here. I mean, it's 12 volt, but it'll do the test. Let's see if that lights up. If I can hold the wires on. And that's the dim bulb tester kicking in under load there. So, let's just unplug it and let's just plug it straight into the mains. Now I could put a bypass switch on this, but I haven't gotten around to it yet. Well, that's it just plugged in, so let's see if it's still outputting. Yes. So the power supply is fine, so the problem's going to be in this. Right, I'll just get this dim bulb tester on that out of the way. And then we'll turn our attention to this. So I'm not sure what screws these are. I've just had a little look through the spyglass. And I'm not sure whether they're Torx or whether they're Allen keys, but a 1.5mm Allen key seems to fit. So I'm going to go with that. Right, so that's all the screws out of it. Now, does it just want to pop apart or something? I'm just going to grab a spudging tool. Try one of these little plectrum type ones here. Right, that's the bezel off. And I'm not sure how the rest of it comes out. I'm not sure if it's got a tease of tape or something. Let's just try one of those at the back. thought it was coming apart too easy. Unless you've got to take the diffusers and things out. I'm just going to flip it over. Well, that doesn't want to come out either. So I'm not sure how this actually comes apart. I'll just pause a moment and I'll see if I can figure out how it actually comes apart. One moment please. Right, well that was a nightmare. So this bit of perspex here with the diffraction grating on or whatever it is actually glued with this double-sided adhesive pad to this aluminium frame. So what I had to do was I managed to get the pry tool in and I could see, just to prise this open slightly, and I could see it deforming in the front here, like the actual plastic was being pulled while the perspex was coming forward, because this diffraction thing there, actually you can see where it's beveled up a bit there. So I've been pouring IPA down here to try and soften the glue, while sort of getting the pry tool down and trying to basically coax it forward. So that's took some right doing, and you can see all the marks there off the pry tool. What that reveals is then 4 Phillips head screws under here, so that's where I'm up to now, and hopefully I haven't damaged this. It looks okay, so fingers crossed on that one. Right, so we've got an LED strip all the way around the edge here, and it looks like it's got two different, it looks like it's got an RGB light in the middle and then a warm and cool LED either side. I'll just zoom down so you can actually see a bit better there. So it looks like we've got an RGB in the middle and then probably a warm and a cool either side. Right, let's remove these screws. A little bit of glare off the aluminium back into the camera, but what can you do? Get that screw in a moment with some tweezers. Let's see if this bit wants to come out now. Right, so looks like there's a bit in this. I'll just undo this bit of tape here and let's see if I can tip that over a bit. Let's put this that way. Let's try and get that out of the light, out of the camera rather. And then let's just zoom down a bit on this board. See if we can see anything. Well, I can see a 0 ohm resistor there, which looks possibly near the power inlet. So where's the power coming? So actually that's on the USB connectors here. So it looks like the power comes in here. So I think we're going to have to take this board out just to have a look to see what's on the other side of it. We have a few little power supplies here. Little power supply here, another little one there, one here. That's to the LEDs. And that probably goes through to the front panel. Not sure what that's for. Could just be an earth for the, just a ground and plane for this possibly. That's what it looks like. Right, I'll undo these screws then. I'll just zoom out a fraction. There we go. Just get a slightly bigger screwdriver. Maybe a slightly smaller one. Looks like there's a further 2 screws just here. Actually, there's another 2 screws that I couldn't quite see there as well. And further 4 screws. So those could possibly be display drivers, because it looks like we've got some display on the other side here. Let's see if this board wants to come out now. I think I'm going to have to unplug this little connector here. This has got glue on it. This looks more like that conductive glue type stuff. And that turns brown after a while and goes conductive. Let's see if we can get that out now. There we go. And that goes to a little board just here. Let's see what's on the other side of this. So, possibly some kind of boost or buck converter there. We've got a big inductor, it looks like a MOSFET or something or two. I'll just spin that round so I can get a better view of it. And there's the Wi-Fi and Bluetooth chips. It looks like we've got a processor here. This is obviously the LED display. That's going to be some USB power supply chip. So I think what we need to do, actually, is add a fuse there possibly. Let's see if I can get this a bit better in shot. No, it's a resistor. Well, can't see anything obvious, can't see any signs of anything blown. Well, I think I'll get the power supply plugged back into it, and then we'll see where we're getting voltages and things, or what voltages we're getting where. Right, I've got the power supply plugged in. Let's see if we're getting voltage into this board. Just untangle my probes a second. Right, so we're getting 15 volts in on this pin here. Let's just try on this inductor here. We've got 40 volts on there. So I guess that must be to supply the LEDs. So it must be getting boosted up. Let's see what we've got on that. Again, 40. Well, we've got voltages there. Let's just try on this little inductor down here. Well, we're getting 5 volts to the USB. Let's just see if that goes off if we switch it off. Yes, it does. Okay, so we've got 5 volts there. Let's just try one of these debug headers. So we've got 3 volts. So I guess that's to supply that microcontroller here. So that's not looking great. And there's another debug header just here. So let's try on that one. Let's get the leads the right way around then. We've got 3.2 volts on there. Although it's fluctuating very, very slightly. Well, this isn't looking too good, is it? If we've got voltages there, I mean, it could be clock problem or something. Let's just zoom down a little bit, see if we can see anything else. I mean, I didn't check that inductor there. Let's just see what we've got on that one. And again, we've got 40 volts on there. It's got a microphone in this. I wonder what the microphone's for. Just noticed that. Just there. I don't think it mentions anything about a microphone in the instructions. Although I've not actually read them, but it just seems a bit unusual, that. Why have they got a microphone in there? Unless it does, like, sound to light type, where it changes colours, maybe. That's the only other thing I could think, where it changes to the music, like flashes to the beat. Wireless ESP8266. That looks like an ESP01, it says there. That's the Bluetooth module. I don't know what that's for. I was thinking maybe like an SD card or something, but it doesn't quite make sense in the position it's in. Plus you wouldn't be to get the card in, so I'm not sure on that one. Well, I might get the thermal camera out and we'll just see if anything's getting hot. I think that's going to be the next thing just to try. Let's see what those two things are down there. Well, that's a 3.3 regulator. 3.3. And that's a 5 volt. So let's see what we're getting on those. So if I just go into ground, let's get the meter in shot as well. 5 volts. 3.3, well, almost. I just hope this isn't some kind of firmware or blown microcontroller, because that would be a shame, wouldn't it? I'll see, I've had a few of those. Right, so I'll go and grab the thermal camera. Right, back with the thermal camera, and this is the Kawitz KTI W02, and if you want one with a bit discount, there's some links in the video description. No, I'm not sure if that's a bit heat around that IC there. I mean, the main microcontroller's not really getting hot or anything. A little bit heat around there, but that might be on the other side of the board, so we'll flip it over in a moment. Right, so just flip this over. So it looks like the 5 volt regulator is getting slightly warm. I mean, nothing really to shout about 28 degrees, so that's probably fine. What's this component here? A little IC there. But again, not overly hot. Well, that hasn't really shown with too much either. I thought I'd get it under the microscope just to have a look over, sort of have a look around this CPU just to see if we can see anything that doesn't look right or whatever. So I'll just zoom in a bit with the microscope and just refocus it. So this is the TOMLOV 4K-AF Max microscope that I'm using. And if you want one of these, there's links in the video description too. I mean, that looks okay. I can't see any dry joints or whatever. Let's see if we can just zoom in a bit more with this. That looks okay. I'll just spin it round. I'm just looking at that one at the end there. I'll just zoom in a little bit. Just that pin. To see if I can point it with my tweezers. Not sure if that's, it must be making contact at the back though, even though it doesn't look like it's soldered very good at the front. Might just be to test that with the meter there. Let's go on to continuity. I'll just go from there to here. Yeah, it's making contact. It just didn't look like it was making contact very good there. Right, let's have a look at the other ICs then. So this is the Bluetooth module. Let's have a look at the other side. Well, that doesn't look too great. I'll just try and get a better view of that for you. And some of the soldering on there doesn't look the best, does it? But those solder joints don't look the best. So I might resolder those with the soldering iron. Let's have a look at the Wi-Fi. Again, the soldering doesn't look great. I might just retouch these up with the soldering iron. Because all it would take, I guess, is just one of these connections not to be making connection properly. And the processor might be stuck in a boot loop. Let's just have a look at the other side. Again, soldering doesn't look the best. Hang on. Is that one making contact even? Yeah, look at that one. I wonder if that's actually making contact. Let's just try that one with the multimeter. Well, it is making contact. Haha, hold on, that one isn't. Or is it? That might be. I think it's some kind of coating on the board. There's a piece of it just there. I think I'm going to resolder these in any case, just to rule it out. Hold on. What? It is actually making contact, but that one looks horrendous. Oh, it doesn't look bad. I think it's just the angle we're viewing it at. Right, well I think I'm going to touch these up with the iron in any case, because they still don't look the best to me. Just in case, just to rule them out, and then we'll see if that makes any difference. In fact, there's a little light on there, but that might just be for the Wi-Fi and not power or something. That might just be when it's connected to Wi-Fi. Yeah, soldering on here looks shocking. It's like... Right, I'm going to touch up all these joints and we'll see how we'll get on after that. Right, I finished soldering all of those contacts up. So those should all be making contact now. And I've gone over the main IC here as well, just to make sure that all of the legs are making proper contact as well. So we'll get the microscope out of the way and we'll plug it in and see what it does now then. Right, let's plug this in and switch it on. And it's still not doing anything. Well, I think I might get the scope set up and we'll just have a poke around, see if we can see any clocks or signals or anything coming out of any of these chips. I think that's going to be the next thing we're going to have to try, and then after that I'm not so sure. Right, I've got the scope set up and I found the data sheet for this chip. So let's just check a few signals. So this pin here is the reset pin. I'll just bring the data sheet up as well so you can see. If I switch it on there, you can see that goes to 3 volts. So the chip's not in reset. The power supply of the chip comes in on these 2 pins here. So let's try and get that from the other side. So we've got power to the chip. And the only other thing that we should have is clock, and there's an 8 megahertz crystal here which goes onto these 2 pins here and here. So now we don't appear to have anything on that pin. Let's try the other pin. And we don't have anything on that pin either. So that's either the crystal isn't working, but then again we've got no voltage on this chip. I would have thought we should have some kind of voltage there, even if it's just a little bit, to make the crystal work, but we've got no voltage on either of those pins. So I don't suspect the crystal, unless it's shorted to ground somehow. I'm leaning more towards this chip's failed, either that or some kind of firmware corruption possibly, if it's took, let's say, like a firmware update and that's failed and the chip's not booting up. But I would have thought it should still have some kind of clock pulse there, regardless. But we've got no clock pulse there whatsoever. I think there's one other supply to the chip, which I think is... it's one of these pins around here somewhere. Could be that one there. And we've got power to that pin as well. So the chip's getting power. It's not in reset, but we've got no clock. I mean, I could try changing the crystal, but I don't think it is that. I think it's the microcontroller. So what we could try is just to see if any of these capacitors are shorted to ground. So let's just try that. And that would be a no. And that would also be a no. Let's just check that we're getting continuity between the crystal and those pins. Yes. Yes. So, unfortunately, I think the microcontroller's gone on this one. Well, that's a shame. but it's not getting hot, and I don't know what could have caused it. I mean, I suppose it could have just failed, but that's very unusual. Microcontrollers don't just usually fail. But with it not having any clock pulse and having no voltage on those pins, that's the only thing I can think could be the problem. And one thing I noticed as well, I'll just show you, we've got a little LED on this module here. If I just switch it on, did you see it just flash there? I'll just switch it on again, and there you go. So I think the ESP32 or whatever it is here is working, or ESP8266, I think that's working, and I would think the Bluetooth's working, but we don't seem to be getting any signals on this chip at all, and we're getting no clock pulse. So and it's getting the correct voltages. There is another voltage here which I've measured. I'll just show you that, because there's an internal voltage on this chip which is a 1.8, I think, which is just across this capacitor here, and there we go, 1.8 volts. So it's like all the voltages are correct, but we've got no clock pulse. So I just thought I'd change the crystal just in case, but I don't think it is that. Now I don't have an 8 megahertz one, but I do have a 16, which should still show us something. Just got a little bit flux to that. Right, let's see if we get a clock signal on it now. We'll just switch it on. And absolutely nothing. Nothing there. Nothing there. Let's just check the reset pin. We've got 3 volts there, so the chip's not in reset. But we've just got no clock still, and that's with a different oscillator. So I'm pretty sure this microcontroller's failed. So I don't know whether we'll be able to do anything with this one, but let us have a think on it and I'll see what I can come up with. So I've been having a little look at the other chips on the board, and these chips here, there's 3 of them in total, the other one's away over here somewhere. If you notice, this pin here goes to a 10k resistor that's pulled down to ground, and it shoots off up to the microcontroller. And there's the same with this one here, and the same with this one here. So what I was thinking was, if we could use a different microcontroller, something like an ESP32 or Arduino or something, and send our own signal into here to control these chips. So there's one here, and one here, which I think control the red, green and blue. And then further down here, I think there's some little tiny chips, which are these ones here. Is it that pin there? I think, yeah, that one there. Pulled down to ground, that 10k, it goes through here, and then it goes off up to the microcontroller as well. So I think one of them's for the warm backlight, and one of them's for the cold backlight. And there's one chip here, and there's another one hidden away. It might possibly be on the other side of the board, if I remember. Yes. And another one here. Let's try and get that in focus. It goes to that pin there, which then goes on the reverse side of the board, and then shoots off up to the microcontroller. So that's where I'm up to with it. So I might try tacking some wires onto various places, and then we'll see if we can control the lights. Right, I've tacked one of the wires onto here just to see which colour this one controls. And if I just touch it there, you can see that controls, it looks like either yellow or the warm backlight. And if I send 3 volts to it, You can see it lights up fully there. So that's one of the control wires. So I'll tack some other wires on once I find out the other colours, and then we'll see if we can wire it up to an ESP32 or something, write a bit code and see if we can control the light that way. Well, I've just finished soldering wires onto different places. So I've got a blue, red, green, white and yellow. So I'll just zoom out a little bit. If I get the red wire, I'll just give 3 volts on that. You can see the red lighting up. I'll do the same with the green. I've got the green lighting up. I've got the blue. I've got the yellow. And we've got the white. So now all I need to do is to write some code on an ESP or something and send it PWM signals into these wires, and hopefully we should have a working light. I mean, we won't have a nice display and that on it, but at least it'll be functional, which is more than what it is now. So that's the ESP all wired up, and it's just booted up there. So this is the web interface, and this is a little bit demo code that I found on the internet, but I had to modify it because the original just did red, green and blue. So I've had to modify it so it does the yellow and white as well. Oh, just turn the green on there. Let's turn that down a little bit so to not over saturate the camera. You can see there, that's the green. If I do the red, or we do a bit red and green, we get yellow. Or a bit red and blue, we should get purple or cyan or whatever. If I go, oh, just hit the green again. If I go here, we've got the yellow, which is the, I guess the natural sort of light it's supposed to be. And that's the cold white. Let's try and turn it on a little bit there. And you can mix them all together, so if you want a bit blue in that, the white light you can see, or a bit yellow. I can turn it, the green right up and the blue down and whatever, but you get the idea. So yeah, it seems to work as expected. Well, I had finished recording the video. That's the little ESP module that I've got wired in the back. And I was chatting to a friend of mine, I was explaining what I'd done, and he said, why didn't you use TAS motor? And I thought, yeah, I remember that, but I hadn't even given it a thought. So I've just got it plugged in here, the light. I'll just try and stand it up on something so it's not falling over there. That'll do for now. So that's what I've done, I've flashed it with this. So now we can turn the brightness up, like that. We can change it from warm to cool white, like so. If I turn that off altogether, we can change the colour of it. We should be able to if I turn that up. So I've got reds or greens, yellow, orange. And if you unplug it, so I've got it set like that at the moment. If I unplug it now and plug it back in, it comes straight back on the last setting. So I think that's working perfect now. I think I'm really happy with that now. Yeah, well happy. And the reason I wanted this light was because when I'm recording videos or doing things, I can use it to give a bit extra light in the room or whatever. So I thought it would come in handy as well. But I think it's even better now, and it's open source. So if you like this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, leave it in the comment section below. And as always, have a great day. Thanks for watching.